Hello, everyone. This is Joy Allen. I am Customer Success Manager for NetApp out of the Michigan office, and I have with me today John DeMasi, and he is going to be presenting to us on using Cloud Volumes ONTAP for disaster recovery. This is the second part of the series, so if you missed the first part and you're interested, just give me an email and I'll forward it over to you if you didn't receive that. And thank you all for joining. And at this point, I'll pass it over to John. And John, you can introduce yourself and take it away.
Thanks, Joy. And good morning, everyone. Thank you so much for setting aside some time out of your busy week to join this webinar. I am very excited to continue our discussion of utilizing Cloud Volumes ONTAP for disaster recovery. And like Joy said, this is part 2 of a 4-part series on the subject. Also, I'd like to mention that I'm joined by my associate, Kyle Coons. We are both Technical Customer Success Program Managers with the NetApp Customer Success Program, supporting all of NetApp's Cloud Data Services products, which includes Cloud Volumes ONTAP, Cloud Volumes Service, OCI, and the upcoming Cloud Insights. So here's the agenda for this morning's session. We're going to start off with a very, very brief recap of session 1. Then we'll have a discussion of the different deployment methods for Cloud Volumes ONTAP and what their architecture looks like. Then we'll have a quick discussion of some considerations for getting ready to replicate from your on-premises NetApp systems into Cloud Volumes ONTAP. So again, I mentioned this in the first session, but this webinar series is intended for people who are currently using on-premises NetApp systems running ONTAP and are interested or currently using Cloud Volumes ONTAP for AWS or Azure as part of their disaster recovery strategy. So without further ado, let's get into the presentation. So here's what we talked about last time. What is Cloud Volumes ONTAP? To put it quite simply, it's a fully fledged version of ONTAP that's been modified to run natively in the AWS and Azure public clouds. It runs by consuming native cloud resources, and it uses the same tools and processes that you're used to from your ONTAP system. It's a really cool service, and one of the most interesting things about it is that it's a mature, proven technology. You know, ONTAP has been around for 25 years. It's been battle tested by enterprises all over the world, but we've modified it so that you can utilize it in this very modern cloud consumption model, which is especially well suited for DR. And by the way, we've been selling Cloud Volumes ONTAP, formerly known as ONTAP Cloud, and I believe before that known as Cloud ONTAP. Since 2014, hundreds of customers have used it. It's reliable, it's proven. And like I said, it's really great for disaster recovery. Here's why. First of all, if you're already running ONTAP on premises, it makes a lot of sense to simply run ONTAP in the cloud for DR. Your teams already know how to manage and use ONTAP, so why waste that knowledge? And it only makes things easier to have consistent storage on premises and in the cloud. And of course, you can use the native SnapMirror replication that you're used to that is incredibly efficient and useful. Also, the cloud resources that Cloud Volumes ONTAP utilizes in AWS and Azure are themselves very reliable. The EC2 and EBS SLA in AWS is 4 nines. And like I said on the previous slide, ONTAP has been around for a long time. It's been proven to be resilient. Last of all, the cloud consumption model of pay-as-you-go, turn it off and on as you need, makes a lot of sense for DR because it's not a site that you're going to be necessarily using every day or running 24 hours. Also, it's just super easy to implement. We showed that last time. You can have a new site of CVO deployed in under 30 minutes, and you can scale it from 0 to 300 terabytes plus. So very useful for this use case. I could tell you from experience, this is the main use case that we see most of our customers using Cloud Volumes ONTAP for today. And yeah, I think that's a pretty good summary of our last session. Any questions at this point? Okay,
Not
excellent.
seeing any in the chat.
Thanks, Kyle. All right, that sounds good. Let's move on to the architecture of Cloud Volumes ONTAP. So I'm going to start by discussing OnCommand Cloud Manager, which we mentioned in the first session. This is actually a free tool that anybody can use at no cost, and it's a management interface for ONTAP. You can use it for your on-premises ONTAP, and you can use it for your Cloud Volumes ONTAP nodes that you've deployed. It's important to mention that you cannot deploy Cloud Volumes ONTAP without using Cloud Manager. It can be a little confusing when you go into the AWS or Azure Marketplace and you want to find Cloud Volumes ONTAP. Those offerings do exist. You'll see them listed. It'll look like you can deploy them directly from the Marketplace. You actually cannot. You have to start with Cloud Manager. You'll want to deploy that into your environment first. Then you give permission to Cloud Manager to allocate AWS resources for your Cloud Volumes ONTAP deployments. So to summarize, start with Cloud Manager. Then you can discover your on-premises ONTAP systems, and you can deploy Cloud Volumes ONTAP or discover Cloud Volumes ONTAP systems if you happen to have any already out there. We do go over this in the first session. If anybody missed that, I would recommend going back and taking a listen. Also, a very interesting point, Cloud Manager can be deployed in the cloud in AWS or Azure, or you can actually deploy it on premises if that makes more sense for your needs. Do we get any questions about Cloud Manager, Kyle?
We have not.
Cool. Okay. So one last thing before we get to some architecture diagrams, I just wanted to put out the various terms that we're going to be using in AWS and Azure. There's a fair amount of terminology, and I thought it would just be useful to get it all out there at once. So we will be using Cloud Compute. That's EC2 in AWS. They call them VMs or virtual machines in Azure. We'll be using block storage as our virtual disk shelves, if you will. In AWS, that's EBS, Elastic Block Storage. In Azure, that's Locally Redundant Storage, or LRS. We will also be using object storage for tiering. That's S3, Simple Storage Service in AWS, Azure Blob in Azure. And of course, this will all be sitting within your network in Hyperscaler Cloud. They call your private network in AWS your virtual private cloud. In Azure, it's your virtual network or your VNet. Okay, let's see how those components come together to support Cloud Volumes ONTAP. So this is what the architecture for a single node deployment looks like. You may recall from the last session that Cloud Volumes ONTAP can be deployed as a single node or in an HA pair. We're going to start by talking about how a single node works, and then I'll show you how an HA pair works. So on the left side of the screen, we have a single node in AWS. And on the right side of the screen, we have a single node in Azure. So we have our VPC and our VNet. Each single node sits within a single subnet inside of your virtual network or VPC. You'll notice the Cloud Manager is on both of these diagrams in that it sits in the same subnet as the rest of the resources. That does not need to be the case. As I said earlier, Cloud Manager can be deployed really anywhere as long as you provide the correct network permissions to let it access your Cloud Volumes ONTAP deployment. Okay, so within each subnet, you'll see that we have ONTAP. This is running on whatever virtual machine service exists in the cloud you're using. So this would be EC2 in AWS. or in a VM in Azure. This EC2 instance is connected to a bunch of block storage devices. So for AWS, you have EBS volumes allocated for your system disks, your root and boot. This would be a single aggregate. Then you have another aggregate of EBS disks that are your data disks, that the data that you're actually adding to the system would be stored on. Same thing in Azure, LRS for system disks, and then LRS for data disks. That's how it all comes together. Any questions on this slide?
Nothing in chat.
Okay. So this is what a single node deployment looks like. It's very useful for DR. It's simple. It's easy to manage, easy to deploy, and it's the least expensive way to utilize Cloud Volumes ONTAP. We also do offer Cloud Volumes ONTAP in a high availability setup. This means that you're deploying 2 nodes of Cloud Volumes ONTAP. Each node looks just like the single nodes, but they're set up with synchronous replication. Currently, this is available in AWS, but great news, it is coming to Azure this winter, so stay tuned for that. That's extremely exciting. Just a note on how the infrastructure works. Like I said, data is synchronously replicated to both nodes, and you do have a fully redundant environment, meaning there's 2 EC2 instances, 2 sets of data disks, 2 sets of system disks. So you can see here why the high availability setup is going to be a little bit more expensive than the single node setup. You are provisioning twice the cloud resources. And I'll just, for HA, I'll just use AWS terminology since it's not available in Azure yet. So you are provisioning twice the EC2 instances, twice the data disk, twice the system disks. And again, this is very important. You are actually going to be purchasing 2 HA nodes. That can be a little confusing because you'll always use an HA node, or you'll always use your HA nodes in pairs. However, they are sold separately. You do get a price break, though, so it doesn't end up being twice the licensing costs. It ends up being more like 1.5 times the licensing cost. Also, your nodes can be configured in an active-active or active-passive setup, and you can spread your resources across multiple AWS availability zones, or you can hold them all in a single availability zone, and we will review the architecture for both. And I will pause for questions after I go through the multi-availability zone architecture. So this diagram should look extremely familiar. It's basically the same thing I just showed you, except we've added a second node and a couple of other things worth explaining. So first of all, again, we're doing this all in a single VPC. You cannot do this in multiple VPCs. You cannot do this across regions. This all happens in one VPC. And again, we have Cloud Manager in the picture. This does not need to be in this VPC. It could be on premises. It could be in one of these subnets. It doesn't really matter as long as the connectivity that we need is maintained. Okay. So you'll notice in this diagram that we have 3 availability zones in play. Now remember, this is the multi-availability zone deployment method. So for this example, we have availability zone A, availability zone B, and availability zone C. Availability zone A and availability zone B contain our nodes. So each one has fully redundant resources. Each one has its own EC2 instance running ONTAP, and a full set of data disks and system disks. You'll see that node A, node B, same thing. We're also adding a third availability zone with what we call the mediator node. So this is another EC2 instance that's going to be running in your VPC. Ideally, it would be in its own availability zone for maximum redundancy. If you happen to be working in a region that doesn't have 3 availability zones, of which there are several, you can always put it in the same availability zone as one of your ONTAP nodes, your Cloud Volumes ONTAP nodes. Should you choose to pursue that deployment method, we suggest configuring your nodes as active, passive, and then putting the mediator node with the active node so that if that availability zone goes down, you'll still have your failover. And I just realized I should have explained what the mediator did before getting into advanced mediator topics. The mediator's job is really just to check on each availability zone and make sure the node in each availability zone is still running. So the mediator is a very small instance, very inexpensive. Its job is really just to ping each node and determine if a failover event is necessary. So the last new thing from this diagram is that we use a floating IP route table in order to coordinate the failover between nodes in the event of one of the nodes becoming unavailable. So this is just a list of IP addresses that's out of the CIDR range of your VPC, and it points to both nodes when everything is working and nothing's gone down. And then in the event that a disaster should strike one of your availability zones. I'm sorry, was there a question? It sounds like somebody got excited about the asteroid. So in this example, an asteroid hits availability zone A. Availability zone A goes down. The mediator node sees that availability zone A is no longer available, and it tells our floating route table to route all traffic that was destined for node A to node B, so that we're able to keep serving data and operating non-disruptively in AWS.
Hey, John, we got a question from John Roush. Any advantages to active-passive setup versus active-active for cost?
I don't believe there are any advantages for cost. Active-active does offer slightly higher write speeds. But they should both be billed the same way. You're using the same resources, and it's licensed the same way from NetApp. I think.
And then we've got another couple questions here. So one is, what's failover time like?
That is a good question. It is very fast. I forget exactly what it is, like 1 or 2 minutes. And the recovery point of the solution is no data loss, since it's synchronized simultaneously. There is no data will be lost if a failover does occur.
Okay, thank you. We had one other question too, and we might need some clarification on this. Asking, is replication happening using ONTAP initiated or cloud initiated replication?
Yeah, I apologize. I don't know the answer to that offhand. I'll have to make a note of that, and we'll take that to the product team.
And whoever asked that, let's see here. So is that, are you asking if it's like a SnapMirror initiated or if it's initiated through AWS? Oh, I saw it in the chat. So if you'd like, we can also follow up with you afterwards.
Yeah, that's my question. Correct.
Okay. So in that case, I believe, and John, we can double check and get you a concrete answer back, but I believe that's actually that synchronous relationship is happening on the AWS end between their EBS storage, whereas SnapMirror is more the relationship you're going to use to get data in and out of your CVO instance. And John, correct me if I'm missing anything there.
No, that sounds right to me, and we'll confirm that.
And then got one more question from Rob here. Are nodes physical, dedicated nodes, or are we getting our own SVM within a cluster and sharing nodes with other tenants?
So the nodes are based on EC2 resources. You do have the option when deploying a node to deploy it on dedicated hardware. That'd be a dedicated AWS instance. But the expectation in the normal way this works is that you'd be sharing the underlying hardware resources in the AWS data center with other tenants.
Perfect. Thank you.
Okay.
And I don't have any other questions at this point.
Awesome. Thanks, Kyle. So that's how the multi-AZ HA architecture works. There are some considerations, though, when deploying this for the disaster recovery use case. First of all, due to just a limitation with AWS called transitive routing, the floating IP route table that makes our failover work in the multi-availability zone setup does not automatically route traffic from outside of your VPC. So this is an awesome solution for people who are running production workloads within their VPC, within AWS. Unfortunately, this limitation does exist when you're running a production workload outside of AWS, outside of your VPC, and you want to be able to fail over into your VPC seamlessly and automatically. When you're working with traffic from on-prem, you would have to manually route it to the surviving node in the event of a failover. Now, there are workarounds for this limitation using third-party products. I don't want to get into that in this discussion today, but I will just drop the name Aviatrix. They do have a solution that addresses this problem, and I believe there are some specifically Aviatrix and NetApp resources that you should be able to easily find on Google if you're interested in pursuing this approach. Also, talk to your NetApp account teams. Transitive routing is something that we deal with every day, and they do have ways of dealing with this problem. Okay, so transitive routing, this is an issue, and we're aware of that. So we actually have another deployment method for Cloud Volumes ONTAP HA, where we put all of your resources in a single availability zone. This helps us avoid the transitive routing issue. As you may notice on this slide, all the components look the same except that we're operating in a single availability zone in a single subnet, and we don't have that floating IP route table. We just have a mediator and then our two nodes of Cloud Volumes ONTAP. So this is an alternative approach that works. You do not have to worry about transitive routing when you're deploying ONTAP Cloud HA into a single availability zone. Any traffic coming from outside the VPC will be routed to the correct node in the event of a failover. And everything works basically the same way. Of course, there is a downside to operating all of your resources in a single availability zone. And by the way, it's worth mentioning just for anyone who's not super comfortable with AWS yet, the term availability zone, when you're talking about AWS, it's basically just a data center. So each AWS region is split into different data centers, and they typically just call those availability zones. So when we say that we're putting all of our resources in a single availability zone, that means that all of our resources are actually connected to the same physical AWS data center. And, the potential issue with that is kind of obvious. You may not get as much redundancy with a single availability zone setup as you would with a multi-availability zone setup. And, worst comes to worst, it's even possible that your EC2 instances and your EBS disks may be running on the same underlying hardware in that data center. And of course, should that data center get hit by an asteroid or a hurricane, or for whatever reason that whole data center becomes unavailable, you don't really have any protection from that contingency. But on the plus side, the floating IP address is completely avoided, which is very helpful. Any questions on that, Kyle?
Nope, none yet. Oh, hold on, we got one that just came through.
Okay.
Does Mediator act as a load balancer?
No, it doesn't. All the Mediator node does is just ping the separate Cloud Volumes ONTAP nodes just to see if they're still running. It doesn't serve any other function outside of that.
And no other questions.
Okay, awesome. So I'm going to conclude our architecture diagrams with just a quick picture of everything put together. So when you have Cloud Volumes ONTAP running in the cloud and you connect it to your on-premises data center for DR, this is what it looks like. You have your on-prem systems running ONTAP, using SnapMirror to connect to Cloud Volumes ONTAP, running in AWS or Azure, using these cloud resources, EC2, EBS, or virtual machines in LRS. Your Cloud Volumes ONTAP is serving up volumes and whatnot, and the protocols that you need running your apps. And all of this, from the data center to the cloud, is being run and managed by, or I should just say managed, by Cloud Manager, which is that free management UI that I showed earlier on. And by the way, if you have any of our other OnCommand solutions like Insights, Unified Manager, by the way, System Manager comes with Cloud Volumes ONTAP, all of those tools you've been using to manage ONTAP still work. You can still use them, and they work just as well as you're used to. Okay. Wanted to make one last note before we move on from architecture, just about how Cloud Volumes ONTAP aggregates differ from the aggregates you're used to in your on-premises systems. So first of all, and this is a big one, RAID 0 is the preferred RAID method for the cloud, typically. It's not a data protection strategy. You know, RAID does not offer any protection from, or RAID 0 does not offer protection from data loss. It's simply striping your data across multiple disks to increase the performance of the aggregates. And this is okay, the fact that it doesn't offer protection from data loss, because EBS and LRS volumes have built-in redundancy. So LRS actually stands for locally redundant storage. There's multiple copies being spread around the region where it sits. EBS is also replicated by AWS. So we're not as concerned about data protection for these volumes, and we're just trying to increase performance using RAID 0. So be aware of that. Also, and we'll get into this again in the next section, but here are the maximum disks per aggregate. AWS 6, Azure 12, and here's the maximum total disk that you can have for a node. Any questions on, go ahead.
We've got a couple questions here. One from Jonathan. Can Cloud Volumes tier to S3 or S3IA?
Yes, it can. Cloud Volumes ONTAP can tier to S3 and S3IA using Fabric Pool. We go into that in some detail in the first session. I probably could have added it to the architecture slides for this one. I didn't want to be confusing, but yes, absolutely can do that.
And one other was, what's the max capacity of disks?
Good question. And I'll actually be able to show the maximum capacity per aggregate in a couple of slides. But in AWS, the biggest disk they offer is 16 terabytes. In Azure, it's 4 terabytes.
Perfect. Thank you.
Awesome. Thanks for the questions, everybody. Okay, so moving on from architecture, getting into, just some things to think about when you are preparing to replicate from your on-premises systems. So first of all, this is extremely important. You have to make sure that the version of ONTAP that you're running in your on-premises data center is compatible with the one that you're going to be running in the cloud for purposes of SnapMirror. So we actually have a interoperability matrix for SnapMirror, and I'll drag that onto the screen in a second. You do not need to be running the same ONTAP version on-prem as you are in the cloud. You just have to check the matrix to make sure that you're able to replicate both ways. The idea is that in the event of a disaster, you'll be able to move your workloads into the cloud seamlessly. And then when things go back to normal, you're going to want to be able to move that data right back from the cloud down to on-prem so that your operations aren't disrupted. And it is worth noting that the features of Cloud Volumes ONTAP do change dramatically depending on the version you are running. For example, if you are running Cloud Volumes ONTAP in Azure, we just had that question about tiering to S3. Tiering to S3 is only supported in the last few versions. It's a relatively new feature in Azure. Just something to keep in mind. The version of Cloud Volumes ONTAP that you're running will end up being really important to the functionality that you're able to get out of the product. And we do have a link here for the SnapMirror interoperability matrix, and this will be sent out to everyone so you can view it yourself. But here's what it looks like. I'm not going to go through reading this. That would be incredibly boring. I'm sure everyone can review this as needed. But you'll notice that you do not need to be running the same version on-prem as you are in the cloud. We do have forward compatibility and backward compatibility. So as you're planning your DR strategy, just make sure you review this information, that you are running versions that will work together. And you can consult your account teams for help figuring that out. Okay, so besides making sure that you're running compatible versions of ONTAP, it's also really important to make sure that none of the volumes that you're looking to replicate into the cloud exceed the maximum aggregate size that we allow for a single node of Cloud Volumes ONTAP. Volumes are a subset of aggregates. You can't have a volume that doesn't fit into an aggregate. So it's very important to understand the maximum aggregate sizes in AWS and Azure. And you'll notice the maximum aggregate size in AWS currently is 96 terabytes. In Azure, it's 48 terabytes. These limitations are based on the type of disk that's available in each hyperscaler. You may recall from a few slides ago, we actually allow fewer disks in AWS than we do in Azure, but because AWS offers such large disk sizes, we're able to offer larger maximum aggregates in AWS than we are in Azure today. But as soon as Azure releases larger disks, these numbers will change. This will be variable, so I would keep an eye on the documentation for Cloud Volumes ONTAP, where we'll keep this information up to date. So make sure that any volumes that you're going to be replicating from on-premises will fit into an aggregate in the hyperscaler that you want. Also, make sure that you understand the maximum capacity limits for a single Cloud Volumes ONTAP deployment. In AWS, you could fit 360 terabytes onto a single node of Cloud Volumes ONTAP. If you're running it HA, it's 360. And in Azure, the maximum is 252 terabytes. And, if you have more data than the maximum, it's not a huge deal. You'll just need to deploy multiple nodes. I'll pause here for questions. Anything about volume sizes or aggregates?
No questions so far.
Okay. So one last consideration to keep in mind, and I know this one is fairly obvious, but I think it merits discussion. So usually when you're deciding what region to deploy cloud resources into, you want to choose a region that's close to your data center to minimize latency. For maybe burst compute or just a hybrid strategy, that makes a lot of sense. Of course, disaster recovery is a different ballgame. The name of the game here being disasters, which are, by definition, disastrous. So you want to make sure that your primary and your DR sites are not located so close together that they'll be impacted by the same disaster. For example, if your primary data center is in Washington, D.C., or in that area, maybe using the Northern Virginia AWS region makes a lot of sense for most of your AWS workloads, but perhaps when you're setting up your DR strategy, you want to put it in Ohio or somewhere a little bit further away, just so that you reduce the chance of the same disaster taking down both of your sites. That would certainly defeat the purpose. Okay.
Got one other question here from John.
Please.
Any additional latency introduced with the Cloud ONTAP versus direct to S2 from a performance standpoint?
Sorry, I'm not sure if I understood the question.
Asking if there's any additional latency introduced with Cloud ONTAP versus direct from a performance standpoint. Direct to, was that, might have been S3, John? Or EBS?
Oh, I don't know about latency, but typically you'll see better performance from Cloud Volumes ONTAP than you would from just standard EBS or LRS disks. And that's because we're able to utilize RAID 0 aggregates that stripe data across all the disks and offer higher performance. Does that answer the question?
Yes, thank you.
Awesome, thanks. Perfect. Okay, so that is actually all the content I had for this session. I would like to pause in a moment for more questions. I'm sure they're out there. But real quick, here's some resources that I pulled together that I think you all will find valuable. First of all, be sure to check out cloud.netapp.com. That's our Cloud Data Services homepage where you can access Cloud Volumes ONTAP, Cloud Volumes Service, Cloud Insights when it comes out, and all of our various very exciting cloud services. Here's a link to the documentation center for all of our products. You could find the documentation for Cloud Volumes ONTAP here, which is really useful and well written. I refer to it constantly. I did mention that Cloud Volumes ONTAP features change dramatically depending on the version you're running. Here are the release notes that tell you about the different versions. And also, I'm assuming you're all subscribed, but in case you aren't subscribed to our mailing list for webinars, please check this out. And here's a link to the first session that we did in case anyone wants to review. By the way, I know I haven't had a chance to meet any of you in person or really have a conversation, but we did do a webinar together, so why not connect with me on social media? Perhaps we could become friends. So I've got a LinkedIn profile. Here's what I look like. Please look me up, connect with me, and let's keep the conversation going. A couple of closing thoughts before I stop for more questions. Again, check out cloud.netapp.com. There's a lot of great stuff there. It's a really nice website. We do offer 30-day trials of Cloud Volumes ONTAP. So if you don't have a DR strategy in place and you're thinking about utilizing Cloud Volumes ONTAP for it, get in touch with your NetApp account team. They'll help you get set up with a POC. You could try it out and see how you like it. And of course, we do webinars every week. Please join us for our next webinar. We really appreciate your attendance and your time, and of course, all of your great questions. So before we wrap it up, and it looks like give everyone a few minutes back in their day, are there any closing questions?
Nothing in the chat.
Excellent. Well, again, thank you everyone so much for your time today. It was such a pleasure speaking with you about Cloud Volumes ONTAP for DR. Please stay tuned for the next one. Part 3 and 4 will be an in-depth look at making all this stuff actually work in practice in AWS and in Azure. It'll be 2 separate sessions, each one focusing on one of the hyperscalers. So yeah, everyone, thanks again. I hope you have a great day and a great rest of your week. Joy, do you have any closing comments before we wrap it up?
Well, I did want to say thank you to John for a wonderful webinar learning session today. I know I learned a lot. Hopefully you did too. And I will be sending the recording and the deck out after the call, probably not until tomorrow morning, but you will all receive that in your email. And thank you very much for your attendance and your time today. Have a great rest of your day. And Kyle, did you want to just briefly speak about Insight?
Yeah, for those of you that haven't dropped off yet, just one reminder, Insight 2018 is coming up, one of the last weeks of October, so we will have more communication about that in our next newsletter as well as the last one we sent out. If any of you guys are interested in attending Insight 2018, our annual storage conference, please reach out to your customer success manager today or your account team. We can get you all the details necessary. Make sure you guys get a chance to come down. So let us know.
Thanks, everyone, for attending. Have a great rest of your day.